So students, today we are gonna understand the topic refraction. Refraction. This topic is important in the boards, NEET or JEE of the class 10th or class 12 chapter. I'm gonna explain the concept that comes in both standards. So let's start with it. What is refraction? Refraction is the sudden change in speed of light when it travels from one medium to any other medium, let's say medium 2. Okay? The sudden change in speed of light when it travels from one medium to another medium is refraction. Should we understand it in a diagrammatic way so you understand it better? I drew a boundary. This is a boundary. Now what's boundary? Boundary separates one medium from another medium. Let's take this medium 1 and this medium 2. Let's say this is rarer, this is denser. Medium 1 is rarer, medium 2 is denser. And what does the boundary do? Boundary separates one medium from another medium, like you have seen in the cricket football ground. What does the boundary do? It separates the ground from the it separates the ground from the crowd. Okay? Similarly, here the boundary separates one medium from another medium. Are we clear on this? Now, perpendicular to boundary at 90 degree there is normal. Here I drew a normal. This is an imaginary line. Now suppose an incident ray descends from here. As it travels from rarer medium to denser medium, it will bend towards the normal, like this. Now, the function or the role of normal is to measure the angle. We always measure the angle from the normal, like from this. This is your angle of incident I, and from here we measure it like this. This is angle of refraction. We always measure it from here, from normal, not like this. This is wrong. Okay? We always measure the angle from the normal. Here I measure the angle from the normal is R, that is angle of refraction. Always mention the arrows from where the light goes. Are we clear on this? Now, sir, we talked about what's refraction. The sudden change in speed of light when it travels from one medium to another medium. But sir, here the direction is changing too. So should we add that the sudden change in speed and direction of light when it travels from one medium to another medium? Yeah, you can add that, but there is a case where the light only changes its speed, not the direction. That is when I send a light towards the direction of normal. Suppose I send a light like this from the normal, it won't change its direction, it will go like this. It will only change its speed, not direction. That's why I did not include the term direction in the definition of refraction. Are we clear on this? When light travels from normal, it won't change its direction, it will only change its speed. Do you want me to give an example on this to understand it better, like logically? Suppose here is a lot of mud, you mean where you go to off-roading with your car, a mud or a rocky area. This is your car. Okay, you are going with your car like this. You are going. Are you changing your direction? No, you are just slowing down your speed when you are going like this, in the straight direction perpendicular to the mud. This is perpendicular to the mud, right? Mud is like this and you are going like this at the 90 degree. Okay? So you are not changing your direction. You are just changing your speed. But suppose you are here. Now this is your car. You want to go like this here. You will, what will you do? You will turn your wheels, you will turn the steering and like go here. So what are you changing now? You are changing the direction and the speed too. Similarly, when the light goes from normal, from here, it only has to change its speed, not direction. But when it comes from an angle, it has to change its direction too, due to difference in wavelength. Okay? Are we clear on this? Yes, we are very clear on this, sir. Now, the next term is refractive index. To understand refraction, we need to understand refractive index too. What's refractive index? Refractive index, we represent it by mu or n. Okay? Represented by mu or n. What is the formula of it? Refractive index. Mu equal to speed of light in vacuum upon speed of light in any medium. Okay? And it will represent it in like mu equal to c by v. C is your speed of light in vacuum and v is your speed of light in medium. We all know the c equal to 3 into 10 to the power 8 meter per second. That's the speed of light in vacuum. So now, sir, we all know the definition and the formula of refractive index. But what's the real meaning of it? How do you define it? How do you explain it? How do you understand it? So to understand it, I will give you an analogy. Okay, an analogy. Like suppose you know about temperature, right? Temperature. What is temperature? Temperature is your degree of hotness and coldness, right? Temperature is your degree of hotness and coldness. Okay? What do you mean by it? Now, suppose you heard that in Sahara Desert, the temperature is 50 degrees Celsius. Damn, 50 degrees Celsius. It must be freaking hot. That must be really hot, you know. You think that it must be really hot. Then you heard in the Antarctica, there is minus 60 degree temperature. You are thinking that it's freaking cold. Your bones must be freezing there. That's what you are thinking, right? So, to express the hotness you are feeling, to express the amount of coldness you are feeling, what term you are using? You are using temperature. Am I right or wrong? You are using temperature to express your feeling of hotness and coldness, right? If you are feeling more hot, that means your temperature must be high. If you are feeling more cold, that means the temperature must be low. Similarly, to measure the change in speed of light when it travels from one medium to another medium, we use refractive index. How much did the speed of light change? It became half, it became 3 by 2. That's what the refractive index tells us. This change in how much the speed of light changed when it traveled from one medium to another medium. That's what the refractive index tells us. Do we get the feel of it? Yes sir, we got the feel of it. For instance, let's take the example. One example, let's take it. Here said the refractive index of glass is 3 by 2. Okay? The refractive index of glass is 3 by 2. Find speed of light in glass medium. How do we find it? We just saw the formula, mu equal to c upon v. What do we have? We have the mu, we have the c. C is your 3 into 10 to the power 8 meter per second. And what do we have next? We need to find the speed of light in medium, that is v. So let's put the formula, it's very simple. We have mu equal to 3 by 2 and speed of light 3 into 10 to the power 8 and v, that is speed of light in glass. We need to find this. So we have to solve this now. Let's put this and v here, 2 here and 3 down like this. V equal to 3 into 10 to the power 8 into 3 into 2 upon 3. It will be 3 cancel themselves. V equal to 2 into 10 to the power 8 meter per second. Now what is this 2 into 10 to the power 8 meter per second? This is speed of light in the glass medium. Are we clear on this? Yes sir, we are clear on this.